In this video, we'll learn how to use decision trees in Python. For this, we will use Scikit Learn. The data set that we'll use for this video is from a competition in Kaggle. I have provided the link to the competition in the description box. This competition is a classification problem where given certain independent variable, the objective is to predict whether a customer will do transactions or not. Kaggle has provided area under the curve as the evaluation metric. If you don't know about area under the curve, a simple Google search will help. I have provided the link to this notebook in the description. It is available both on Kaggle's website as well as on GitHub. Now let's dive into the code. First, we'll import all the important and relevant modules. The most important for our exercise is decision tree classifier, which we'll look at later on. Next, let's look at what is the data that is available for this problem statement. We have three CSV files available. We have train.csv, test.csv, and sample submissions.csv. The most important one is train.csv, which provides us with all the data that is required for us to build and train our decision tree. So the first step is to read the input data, which is in this case the training data. We'll use pandas read CSV function to read our CSV file. You can look at how the data looks like for train.csv. The first column is ID underscore code, which is a unique identifier for a particular customer or a particular observation. The second column is the target variable, which is the dependent variable. The value of this column will be either 1 and 0, and this is what we want to train the model on, or this is what the model has to learn to predict. Next, there are 200 variables, which are the independent variables which will be used for creating the decision tree. Kaggle's website provides a profiling of these 200 variables, which provides information about the distribution of each of these variables as well as information about missing values and so on. The data is pretty much clean, so I won't go into the step of cleaning this data. But one thing which we'll do is we'll check the event rate in our data. So by just a simple group by on the target variable, we are able to find what the event rate is. The event rate for this is approximately 10%. Right. The next step is that we need to split the df underscore train data frame into training and validation data sets. So for that, dot lock operator for a data frame, a pandas data frame can help us identify the x and y variable. X will contain all the independent variable, y will be our dependent variable. Scikit-learn provides a function which is train underscore test underscore split, which can help us split the data into test and validation samples randomly. Test underscore size provides information about what should be the size of the training data set. In this case, it is mentioned as 0.2, which means that 20% of the observation will randomly be assigned to the validation set, and the remaining 80% will be assigned to the training data set. As you can see, the output of the dot shape attribute for each of these data frame, these have been split into 80:20 ratio. Okay, now we reach the main step, which is creating our simple decision tree. For this, as I mentioned previously, we'll use decision tree classifier. We'll create an instance or a object of this class. We'll provide certain attributes, certain variables will pass on while creating this model underscore tree object. First is the maximum number of leaf nodes that will be used for creating the tree. In this case, we have mentioned that as 8. The second is class weights, and this is important to specify in this particular decision tree for the type of data that we have. Our event rate is not 50%, which means the number of ones and zeros in our training data are not equal. And that is why we have to specify class weights is equal to balanced. If your data was in such a way that the event rate was 50%, this might not be required. But in this case, this is actually required. Okay, after we have created model underscore tree, we'll call the fit function over it, pass on our training data, both X and Y's, and that will actually create the final structure of the tree. It will create the nodes and the splits for each of the variables that are being passed into the decision tree. Let's look at how this decision tree actually looks like. So this is a simple piece of code which can plot the decision tree that we have. You can look at this decision tree in more detail once you have access to the notebook. I will quickly tell a few things which will be available in this particular plot. You will know at each node what is the variable that is being used for splitting, what is the threshold at which the split has happened, what is the Gini value for its split or for the leaf node, how many samples are available in a particular node, and what is the class that is assigned to that particular node. So once we have looked at what the decision tree looks like, the next thing is to use this tree to predict the value of the dependent variable. We'll do that both for the training data set and the validation data set so that we can understand how good the decision tree is in predicting both the training data as well as the validation data's dependent variable. So we have created y underscore train pred and y underscore valid underscore pred. We'll pass on these two to a function which is called rock underscore AUC score. This essentially will tell you what is the area under curve score for both the training and test data set. So we have passed training data set as well as the validation data set, and we have printed what is the AUC value for both of these data set. The AUC value that we are getting for train and validation is in reasonable range. It's not very high, but for now it will be something that will be okay with. Okay, so when we were building a simple decision tree, we just assumed and put the maximum number of leaf nodes to be 8. Generally, we won't do that. We need to find out what is the point where we get the maximum performance in terms of the maximum number of leaf nodes. So we'll iterate over various values of number of leaf nodes to find the appropriate threshold. For that, what we'll do is we'll create a function. In this case, I've created a function called tree training, which will essentially encapsulate all the steps that we have done previously, from training the model to predicting the value of dependent variables on both training and validation data set, and then calculating the AOC score, and then essentially printing the value of these AOC scores. We'll run this function in a loop where we will be passing the value of max leaf nodes through this loop, and we'll iterate over values from 2 to 19. You can look at this output and you will observe that for node is equal to 6, we find that the validation AOC is highest. You will actually observe that for node 19 it is more, but node is equal to 6 will give us the best performance for least number of nodes. So it's the simplest tree which will give us very high performance. Okay, so while we have decided that node is equal to 6 might be something that will work, but another way we can validate our data set, another way we can do better evaluation of our model is using a k-fold cross-validation approach. You can get details of k-fold cross-validation by a simple Google search. In this case, we'll do a 5-fold cross-validation. And there are two different ways in which Scikit-Learn allows you to do k-fold cross-validation. The first step is by using something called k-fold, where you specify the value of k, which in this case is 5. You specify whether the data needs to be shuffled before it needs to be split into 5 different sets, and essentially creates this object, which is an iterator, which we have named as k-fold. Now, what this iterator gives is for every time we call this call values from this iterator, it will give us the indexes of both training and validation dataset, and then we can use these indexes to actually for every iteration find what our x's and y's for training and validation will be. So once we have the x and y for train and validation for one particular iteration, we'll call the same function that we had defined before. We'll pass the values of different max leaf nodes and then iterate over and find out what the AUC value is. As you can see, it generates a long output and it's actually not very easy to understand. A way to simplify this will be to average out the AUC value for a particular iteration. So what I mean by that is, let's say there are 5 iterations that we are running. What we'll do is we'll average the 5 AUC score that we get from each of these iteration, and that will give us a representative or average value of how the performance will be across the 5 splits that we have in the data. So this was the first approach of doing k-fold cross-validation. The second approach is to use a function called cross-validate, which is again available in Scikit Learn. Now, cross-validate function requires us to provide a evaluation metric or a scorer, and the scorer should be a function of this format, which takes in the model as the input, x as the input, and y as the input. So there are 3 arguments, and this kind of a format is required by the scorer. So what we have done is we have created a wrapper around the rock AOC score so that it is able to be used as a cross-validation input. In this case, what we'll do is, this is the second way we'll use cross-validation. So first thing is we'll define our model. We'll use cross-validate where we'll pass this model object, will pass our x and y, which is the entire training data, which is not just the 80% initial training data. This is the entire train.csv. We'll provide the value of CV, which is essentially the k value in k-fold cross-validation. We are providing the scoring function, and a return underscore train underscore score is set to true, which means that for every iteration, this will return the score for the training data set as well. So as I mentioned, what we can do to simplify the output is take the mean of all the iterations. So that is what we have done. We have used numpy.mean to find what is the average AOC for the training data set and the test data set. And then we are looping over several values of leaf nodes. And this is the kind of output that we'll get here. Now, in this case, you will observe that for nodes is equal to 8, we get a high AOC value. So the AOC peaks at that point. Obviously, it increases after that. But what is the minimum number of nodes for which we get a peak in the data? That is for node 8. So for now, let's stick with node is equal to 8. Okay, so now we have the details of how many maximum leaf nodes that we need. So we'll use that as the final step to create our final model. We'll go over the same steps. We'll use decision tree classifier, specify the maximum leaf node, specify that class weights is balanced, fit the tree, plot the tree. We can look at how it looks like. We can identify what the AOC value is. In this case, a slightly different approach is used for identifying what the AOC value is. The first step in this approach is using matrix underscore rock curve, which will give you the false positive rate and the true positive rate. And then the false positive rate and true positive rate are passed to matrix.AOC, which will give you the AOC value. Now, why this was done is because false positive rate and true positive rate can be used by us to plot the rock curve, and that is what we have done below this. So this simple piece of code will help you just visualize how the rock curve looks like. The orange line is the one which is above the blue dotted line, which means that we are performing better than a random selection or no model. Okay, now that we have the final model, finally what we'll do is we'll use that model to find predictions for the test data where the target variable is unknown, and we can use this predictions to submit to Kaggle, right? So what we'll first do is use again pandas read CSV function to read the test.csv file. As you can see, in this output, test.csv does not have a target variable column. We'll also read sample submissions.csv. In this case, what we'll observe is that there are only two columns. There is ID code and target. When we read it from CSV, target is all zeros. What we'll do is we'll replace this column of targets with our predictions, and that is what we have done above this. So what we have done is we have created all the X or the independent variable from the test data and use modeled underscore tree dot predict to find the predictions or the Y value for our test data. Finally, what we'll do is we'll replace the target column with Y underscore test underscore pred. And this is our final data set, which we can now export to CSV using two CSV function and then can submit it to Kaggle. So this is how we can use Scikit Learn to create decision tree in Python. If you have any questions, feel free to ask them in the comment section. Thank you for watching the video.